Hi, I'm Phil, and I've been exploring the FarmBeat architectures and extending them in the last couple of months. So just to review what I've done already, here is a typical arrangement that I have in the back garden of two FarmBeat stations, and I'm using Raspberry Pi Model 3 and 4 for these, and recently I've been exploring the use of the re-terminal. And for the sensors, these kits use the DH11 for temperature, humidity, and pressure. They also measure sunlight and soil temperature and soil moisture. And there is one actuator, which is a relay to control the pump for watering the plants. Now, besides the hardware, FarmBeats comes with software, and everything's included straight out of the box, including Python to drive the sensors and provide an overall feedback control system so that the plants can be watered, or the relay can be used to turn on the lights if you feel that additional resources are needed there. And the data is fed via Microsoft Data Streamer to an Excel spreadsheet, which is provided by Microsoft. So the FarmBeat stations, I've extended those. And here's an example using an M5 core. And in the photo, I'm using the M5 Tough computer, which is weatherproof, much more suitable for outdoors. The sensors are similar, and the actuator combines both on the one unit, the soil moisture sensor and the pump. And for software, I'm using UI Flow and the Arduino IDE programming in C++ on some occasions. So here are the other weather stations, and there are three of them. There's the weather station, the GPS station, and the environmental. And all of these measure temperature, humidity, and pressure, but the weather station adds the wind and rain measurements to that. The mobile stations have GPS on them, and they can also record parameters in the farm and feed those to the farm data server. And my prototype GPS, which would go on a drone, for example, is measuring here longitude, latitude, altitude. It gets the time, the GPS time, and I'm, in addition to measuring temperature, humidity, and pressure, I'm also measuring light. Weather stations, this is an example of one which I've got in weatherproof boxes for the electronics and the Raspberry Pi computer and solar panel. And I'm using Python for the lower level and Node-RED for the upper level. And that allows me to communicate via Wi-Fi and MQTT data. And a typical example of how I'm powering these with solar panels is shown here on the photo. And I'm using a WaveShare solar power manager that feeds lithium batteries and keeps everything alive round the clock. And you can see the weatherproof boxes, and everything is normally totally enclosed. So let's have a look at the architecture. So here is an example of the Raspberry Pi, and it's used for sensing and controlling. Well, the control has the help of Microsoft Excel spreadsheet, but I'm also using Node-RED. And in this case, I'm using the Raspberry Pi as a Wi-Fi AP, and it can talk to slave stations. So here, it can either be the FarmBeats hardware, or it can be the weather station. And most of the time it's collecting data, but on the FarmBeats hardware, there's the actuator, which is the water pump. And as a slave, I'm using the M5 devices, and typical stations are the environmental station and the GNSS station to collect the geographic information data. And as the Raspberry Pi is the master, it can collect data from a local slave. And it can also send data via Wi-Fi or LoRaWan radio to the farm data server. And the Windows PC hangs off that and allows the FarmBeats spreadsheet on Microsoft Excel to operate. Here we have an example of a FarmBeats cluster using the extended FarmBeats architecture. So there's two stations, or three stations here. There's a weather station on the top, and down below, over here, there's the two stations. One's a GPS station for position and environmental, and the other one is an environmental station. So let's have a look at each of these individually. So the weather station is collecting environmental data on temperature, pressure and humidity, and it's also collecting data from the wind and the rain detectors. And if we go down further, we can have a look at the other sensors. So here are two other stations. The one on the ground is the GPS station, and if we just hone in on that, you can see that it's got a M5 stack computer, and it's currently showing the longitude and latitude, and also the other parameters of GPS. But there's also on board a number of sensors, including temperature, humidity, pressure, and also a daylight sensor. And over here we have two modules, and all these modules are in weatherproof boxes. We have a power unit which has batteries. It's charging the batteries using solar power, and next to that we have an environmental monitor that's monitoring dust particles, PM 2.5, and also equivalent carbon dioxide. And inside we have another weather station driven by a Raspberry Pi and a PC, and all the data eventually goes to Node-RED, and simultaneously it goes to MQTT Explorer. So let's have a look at each of these components separately. So over here we have the weather station indoors, and it's on a Raspberry Pi, and it's also transmitting its data. And this is an example of the two sets of data from outside. On the left there's the GPS data, and on the right we have the data flows from the environmental monitor, and all of those are shown over here. So you can see the data being captured in real time on Node-RED. And similarly, we have on MQTT Explorer the data being captured. So we've got the environmental data on top, and then we've got the GPS data. So both of those stations have the temperature, humidity and pressure, and the environmental station also has carbon dioxide and PM 2.5 monitoring. The GPS has a digital light, so the light parameter there is in lux, and it also has temperature, humidity and pressure monitoring together with the GPS coordinates.